Yeah.
All right.
It got taken down to like 6
Let's get
countries.
going.
If you're in that country, you follow me.
All right. Today, let's finish out our little transformations units. So, I think we skipped this question.
Yes, we did.
All right, so let's go back and take a look at this one. So again, select all that apply question. So we just want to think about all of these as true or false. All right, we've got 5 true or false questions here. So it says select all of the transformations that would guarantee triangle MNO and PQR are congruent. Right? If we're taking triangle MNO and transforming it to produce PQR.
Congruent means same, right?
Congruent means exactly the same, right? That's a key. Okay? Congruent is same size, same shape.
Okay, then really, any of these would keep it that way because it's not going to disfigure it. It's just going to spin it.
So there's one type of transformation that will change the size. With dilation, right? So any of these that include a dilation, that's going to change the size. That's the only key here. The rest of them won't change the size or the shape. Right? A translation, rotation, and reflection, right? Just rotate, flip, just move it around, but it doesn't change the shape. The only thing that changes the shape is a dilation. A dilation. That's it. Right? So which of these would guarantee that my 2 triangles are congruent?
The last C.
The last 3, right? Anything that doesn't include a dilation.
I like those.
Not too bad, right? So key to remember is that a dilation changes the size. Okay? You okay with that one?
Yes.
All right.
Sir. 3, 5.
Nope.
Let's jump down to this one. This one? Yeah, we just go in there. All right. So we've got this parallelogram. We're told points E and F are the midpoints of their respective sides. And then the question asks us, which transformation carries the parallelogram onto itself? What does that mean?
Back on.
Yeah, we're going to do one of these things, and it just ends up in the exact same spot. Right? So, first, a reflection across line segment AC. So if I draw in this line segment, and I fold across that line, will it look exactly the same? Will both sides match up exactly?
Yes.
I see some no's and some yeses. If you're not sure, try it. I mean, draw the line and fold your paper. Right? Fold it over that line and see if it matches up.
It's just hard because this paper's so small.
It is, you're right.
This paper so small.
It is pretty small. I printed it out. Tiny.
I'm not complaining.
But on the actual air test, right, you're not even going to have a printed copy. You would have to trace the figure on the computer screen. And again, we're going to try to give you guys patty paper for the actual test next week.
Well, I don't want to get in trouble.
What's that?
They're going to be like, what you drawing?
Like tracing paper?
Oh, like the
Yeah,
transparent
patty.
stuff?
Yeah.
Oh.
I say no. Those corners are not the same.
Yeah, so if I think about folding across this line, I think point D would kind of end up right here. It wouldn't match up with B, and B would kind of end up like right here. It wouldn't match up exactly with D. Right? So that first answer I don't think would work. How about B, a reflection across line segment EF?
That one.
So if I draw a line right through here and fold across that line, will it match up?
I think so.
Again, I see some no's and some yeses. So think about if I fold directly across that line, C is going to end up like right here. B would end up right here. Okay? So it's not going to match up, right? It's not going to match up. All right? How about C, a rotation of 180 degrees clockwise about the origin? So that's like putting your finger on the origin and spinning your paper 180 degrees, right? Will the parallelogram end up in the exact same spot? No, right? It would end up down here. Okay? So that one doesn't work. So hopefully the last one works. A rotation of 180 degrees clockwise about the center of the parallelogram. So what that's saying is put your finger in the middle of the parallelogram and spin it 180 degrees. Will it look exactly the same then? Yeah. Right? If we put our finger here and spin our paper halfway around, it would look exactly the same. Alright? You okay with that one?
I suppose.
You supposes.
I suppose.
Alright. It's another similar type question here. Okay? We've got square ABCD. So this is my original figure, is transformed to create this one. A prime, B prime, C prime, D prime. And we want to select all of the transformations down here that could have been performed to get from here to here. So again, we just have to go one at a time. Think of it as a true or false, or 5 true or false questions. One what? 1/8?
180.
Oh, 180. Let's
180.
180. 180.
let's go one at a time. Let's start with the first one. So where is the line y equals x?
Let's do the diagonal.
Yeah, so it would be this line right here, right? So if I take this figure and reflect it across the line y equals x, could it produce this?
Yeah.
Wait, I'm confused what you just said.
So we just took this square, and if I flip it across the line y equals x, could it produce this square?
No, that's not. It's across the line, not like that.
Right, all I'm doing is taking this square and flipping it across the line. It would end up in the exact same spot, right? D would end up where B is, B would end up where D is, A would move, C would move. This square wouldn't end up down here if I flip it across this line. It would actually stay in the same spot. Right? So this one wouldn't work. Right? How about a reflection across the line y equals negative 2x? Where's that line?
Right
Right where? Here?
Yep. Oh. He goes down. Left. My left. What?
Where's the line y equals negative 2x?
Oh, why? I think that
The line y equals negative 2x. Where would that line be?
yeah.
Would be on the x-axis.
Well, where would it intersect the x-axis? So, I mean, this is, if we think about this in slope-intercept form, right? This would be my m, and there's no b, so we could just say it's plus 0. So what's my y-intercept? 0. And what's my slope? Negative 2. So, exactly. Right? So I would go down to right 1, down to right 1, down to right 1. So this is what that line would look like. So, if I were to flip this square across this line, would it end up right there?
Yeah.
What do you think? Right. So we want to match up. Right? We cross that line. I think it would end up kind of like right here. Right?
It's an estimate, Mikey.
Think about drawing a straight line to that line of reflection and then going that same distance across.
Oh, because then it's not like a 1-1 slope.
Exactly.
Oh.
If this were negative x, if it were this line here, I think that would work. But since it's negative 2x, I think the square would end up like up here somewhere.
Yeah.
So again, I don't think this one works either. A rotation of 180 degrees clockwise about the origin, will that end up in the same spot? so. Right? If we put our finger right in the middle of the paper and flip half a turn, I think that one works. Right? How about, what's the next one?
A reflection across the x-axis and then a reflection across the y-axis.
So, taking this figure, flipping it across the x-axis, and then taking that, flipping it across the y.
Yeah.
That would end up in that spot, right? So we get the third one and the fourth one would work. How about the last one? A rotation of 270 degrees counterclockwise about the origin, then a reflection across the x-axis. So this one's kind of tricky, right? What was it? Counterclockwise. So if I take this and go 270 counterclockwise, where will I end up?
In one place.
Quadrant 2.
So which way is counterclockwise? Is it
Oh,
this
wait,
way
that
or
way.
this way?
The first,
That
Yeah.
way I was
the left.
Yeah, so if I go 270, I would end up here, right? Then it says followed by a reflection in the x-axis. So if I'm here and I reflect in the x-axis, I would end up back up here.
You'll be training down there.
Right, and we're trying to get down here, so that would not work. Right, so the only two that end up working are C and D. Alright, this one was a little bit trickier to visualize. Alright. We okay with that one though? So obviously we've seen a lot of these select all that apply questions for transformations. Those seem to be pretty popular. Okay? They also like the idea of seeing if you know which transformations preserve congruence. So it says Kyle performs a transformation on a triangle. The resulting triangle is similar but not congruent to the original triangle. What did he do? Dilation, reflection, rotation, translation. So what's the only one that makes the triangles not congruent? Dilation. Right? That's been a popular idea, making sure that you know that a dilation does not preserve the size. You okay with that one? All right. So then let's take a look at a few questions where we actually have to do some dilations. So we've got a triangle, and we're given the coordinates of all three vertices, 1, 1, 2.53, 0, negative 3. It says it's dilated by a scale factor of 1/2 to create a new triangle, A prime, B prime, C prime. All we want to know is the length of B prime, C prime. How could I go about doing that?
Oh wait, don't you flip them?
No, well, no, you just subtract pretty much like 0 from 2.5 and then negative 3 from 3, and you get that, and then you just divide it by half. Would that work?
That, no. That actually wouldn't give us any information. I was thinking that would be midpoint, but that's not even midpoint.
Or would you just divide the 2.5? Oh no, you try to find B to C. So you just divide both those points by half, right? And then subtract whatever.
So if I want the length of a side, what am I ultimately
Finding the distance between
finding the distance between 2 points. So how do I find distance between 2 points? And this is actually something that's changed this year. Before, when you guys took the test, you did not have the distance formula on the reference sheet. This year, you do now have the distance formula on the reference sheet.
Probably because there's no distance question.
This one we need the distance formula.
Yeah, but this one's what? How many years ago?
I know this is from the practice test, so this is like 4 years old.
Oh.
Yeah.
They released this, I think, in 2015.
Jeez.
So the distance formula, which you don't have to memorize anymore, this is on the reference sheet now. So if you are taking the air test next week, you do not have to have that memorized. You just have to understand when and how to use it.
Did we already get like our papers back to say that we are taking the air test? Or
I don't know if they've sent those out yet. Do you know?
I know they sent an English one out.
What time are those tests? They're in the morning,
They're
right?
in the morning, yeah.
I don't know whether or not
I can look it up for you
Here,
here.
it's 1, 2, and 3.
because I helped it got it.
You said mine looked good. This don't have one point.
Wait,
Yeah,
you said
you're
these are
Down
next week,
skipping,
right?
Yeah.
What day again?
Well, the geometry one is Tuesday, and the algebra one is Friday. I don't remember when the other
Video
ones are.
one?
I'm old
So I care about that.
I am.
Okay.
Thank
All right, so I'm given A, B, and C, but I want to find the length of B prime, C prime. What should I do here? Should I find the length of BC first, and then do something with this scale factor, or should I try to do something with the scale factor, and then find the length of B prime, C prime? I don't know. What do you guys think?
I think you should plug it on in, get the answer, and then plug it.
So you want to find the length of BC first? Yeah, I think that would probably be the best way to do it. Okay. So I can say that this is my x1, y1, x2, y2. And if I want to find the distance between B and C, I just plug these into my formula. And so I guess I'll actually say this is BC. So square root of x2 is 0 minus 2.5 squared plus -3 minus 3 squared. Now, I can actually plug that whole thing into the calculator just like that. Okay, I don't have to try to do this by hand and then square by hand. Right? I can plug it into the calculator exactly like that. If we do that, that gives us fewer opportunities to make a mistake. So if we plug that whole thing into a calculator, what do we get? I mean, plug it in exactly like that. Use parentheses. Put the squares in those places.
Took my calculator. That's not right. Shut up. Wait, is my calculator supposed to be in degree, right?
Yeah, I mean, for this it doesn't matter.
Okay.
But yes, everything we do when we do need radians or degrees is in degrees.
Okay. I got 6.5.
I think that's right. So the length of BC in my original triangle is 6.5. How do I find the length of B prime C prime then?
Scale factor.
Yeah, just half it, right? If I'm dilating the triangle by a scale factor of 1/2, that just means this new triangle is going to be half the size of my old triangle. So all the lengths are going to be half. So B prime C prime will just be 1/2 of BC. So 1/2 of 6.5 gets me 3.25. So that is my answer. 3.25.
Woo!
That's the excitement.
Shut up.
Orange juice.
Oh my gosh.
Shut up, man. He's a good guy.
It's because we didn't know the square root. So it's the square root of all of that. Let me see.
It wasn't even expressed.
It was.
Okay.
She's like, oh, I know.
All right. Any other questions on this one?
I think there's a couple more.
Well, I only have one more.
Yeah, I guess there is just one more.
Booga booga.
Booga booga. Alright. On this one,
It says a translation is applied to PQR to create P prime, Q prime, R prime. So, which one am I starting with then? Am I starting with this triangle or starting with this triangle? This one, right? So,
No, I have
what
one
I want
more.
to do, okay, it says, I'm told it's a translation, right? A translation just means I'm sliding the triangles. So it tells me, okay, can't quite fit that all on there. It says, let the statement xy to AB describe the translation. We want to create equations for A in terms of x and B in terms of y that describe this translation. So how would we do that? How would I figure out this what's going on in this translation? Yeah, so I wanna look at my coordinates. So I just want to look at like one set of coordinates, like from P to P prime. What did we do to get from P to P prime? How far over, and then how far up or down do we go? Yeah. Now, direction does matter, right? So since I moved to the left, should that be a positive or negative 4? Negative. And then since I moved up, is that a positive or negative 3? Positive, right? So now, when I'm writing my equations here to describe this motion, they were pretty picky on the actual test with how they wanted you to write it. So it says create an equation for A in terms of x. Right? How can I describe the motion of, so what am I doing to each x coordinate? Right? X is left and right. Right? So if I am saying I move forward to the left, what am I doing to the x coordinate to get from P to P prime? It's kind of, I don't know if I worded that best, but so we want to think about what we're doing in the x direction, right? We said we're moving left 4 coordinates, but how do I take that information and write that as an equation here in terms of x? So we're saying that my new a coordinate, so what am I doing to this x coordinate to get my new a coordinate? Subtracting 4, exactly. So the way that we want to write that, I'm saying I'm taking my old x coordinate and subtracting 4. And y we're adding 3. Exactly. So I would write that as y plus 3. Alright, now, they were kind of picky on this. If you just wrote negative 4 and just wrote 3, they marked that as wrong. Right?
Rude.
It's rude.
I don't even know what they're doing.
So, since they specified writing equations in terms of x and in terms of y, they did get picky in the answers. Right? How do we feel about transformations here?
Not bad.
Right? This is a pretty common thing that will show up on the air test. Right? I can absolutely guarantee you will see questions about transformations. I mean, we just don't know exactly how those questions are going to be presented. But
Stupidly.
sometimes.
All the time.
Alright, So that went a lot quicker than I thought it would today. Any questions on transformations?